Everyone, this video is an exercise 9C question 6. So we have a crane on AB of length 80 meters which is anchored at point B at an angle of 40 degrees, which is here. And the important part, which is very important in terms of understanding what's really going on, is basically here that a wrecking ball is suspended on a cable of length 60 meters from A. So we want to find angle X through which the wrecking ball rotates as it passes the point level with the base of the crane arm. So essentially, this is the important part because we have this wrecking ball which rotates about A. So the path is basically so it's this is basically essentially that wrecking ball, which means that if here is 60 meters, then also here is 60 meters. So it's kind of like the analogy is like that it's part of a circle center that's A with radius 60 meters. So every position of the ball is therefore exactly 60 meters from A. So that's essentially what's happening here. And interestingly, this means that we have an isosceles triangle, which is going to be very helpful in this question. Right. So the first thing we can do is actually just looking at the left triangle. And we have this side length and the opposite angle to that. And we also have this side angle, but not the opposite angle to that. So this is the ideal condition for the sine rule. So we can essentially start by, let's say here is this angle is A. So, well, let's use a different letter because it can be a bit confusing in terms of the notation that already exists. So let's say this is angle D, and now we can basically do sine D over 80 is equal to sine 40 over 60, which means that we need to rearrange this. So sine 40 times 80 over 60. And now we find the sine inverse of the right hand side. And remember that we get two values when we do the sine inverse. We have two values essentially, because again, this is because of the fact that, as we discussed in the previous lesson, that sine theta is equal to sine 180 minus theta. So because one of the values that we get is 59, and when we do 180 minus that, the other value is 121 degrees. So that means there are two possibilities. However, from the shape that we are given, we can already see that this is an obtuse angle. So therefore, in this case, the answer is 121 degrees. So now that we know that this angle is 121 degrees, then we can simply work out this angle, which is 180 minus 121, and that is 59 degrees. But remember that this is an isosceles triangle. So if here is 59, then here is also 59, and therefore x is equal to 180 minus 59 times 2, which gives us 62 degrees. Now, in part B, we want to write down one modeling assumption that we made. So one assumption is that the ball is basically swinging symmetrically, or actually the cable basically remains taut, and it has a constant length of 60 meters in all positions. So these are all the modeling assumptions that are used to simplify this problem.